We will start the second class with Professor Hans about LCA. Professor Hans.
Thank you.
Thank you very much. Enjoy.
Boa tarde. So, actually, you're discussing about life cycle assessment. Why life cycle assessment? It's actually a tool that you can use in eco-design. Normally, it's very common to just act to design related to technical principles and to forget about the environmental effects. So LCA is a tool that makes it possible to include environmental effects in the design process. So, what we have discussed is a little bit about the framework. The idea with LCA is of course, first of all, to design why am I doing this LCA. Of course, I have to know why I'm doing it. Is it related to some governmental, some laws, or to a production company, or what? And as you remember, there is a critical thing to reflect on. It's about the functional unit, the function. The function of a detergent, as we discussed, is of course not the mass or the volume. It's of course the capacity to clean clothes that is the function. Therefore, of course, if we shall compare different detergents, we have to reflect on the function, the functional unit. In this case, the functional unit was 1 kilogram of clean laundry, as an example. And then we can decide the mass of each product and we can start to calculate. And when we have calculated and decided the functional unit, we have to calculate all streams in the entire flow sheet. All streams that are connected to describe the production process from the cradle to the grave. After, we can do an inventory. And what is an inventory? This is to summarize all the emissions, all the resource use that are connected to this product. After, we can express all emissions in different things. As an example, global warming. Then we knew how much global warming this product is responsible for. And I can compare, for example, these two detergents in relation to global warming. This detergent will create so much of global warming in the whole life cycle, and the other one will create so much. And if I want to optimize the global warming, I choose this detergent. So this is the idea. And after, of course, I look on the results. Maybe I can see that just one part of this process is the critical one, and then I can focus in the critical one to make the entire product more environmental friendly. And as well, if I'm a political person, I maybe would like to do strategic planning. How shall we develop the waste management in that time? Which infrastructure should be the best for the future? Things like that. And as well, of course, marketing. I want to sell more, like all businessmen want to do. And of course, it's one type of marketing instrument is of course to show which product that has the best environmental effect. And of course, it can be something else. Functional unit, very critical. And what we have to do is, in the flow sheet, the functional unit corresponds to a reference flow to which all other model flows of the system are related. So what we have to do is to solve a material balance. I have to solve a material balance related to the reference flow. If this is the reference flow, it has to be the functional unit that decides this reference flow. Then I can start to calculate and solve all streams related. So, the functional unit corresponds to a reference flow to which all other model flows of the system are related. Then it's a question of material and energy balances all over the system. In comparative studies, the choice of the functional unit is very critical. If bad, the study will show a wrong result. So therefore we have to reflect a little bit more on functional unit. This we discussed a little bit. Which is the functional unit if you compare a cup made of plastic which you use one time and a cup made of glass which you use many times. We discussed this the last time, but we maybe can compare, make a repetition of the thinking. What's the function of glasses? Drinking. It's drinking. Not the weight, not the volume, it's drinking, a specific volume. So then I can choose maybe 1,000 of drinking times as a functional unit. And then how much, then I can see that I have to use maybe 1,000 of plastics, maybe less because I use it maybe more than one time. But if I use it one time, it will be 1,000. And the cup made of glass, which you use many times, maybe it crashed after 500 drinking times. Then I need 2 glasses and 1,000 plastics cups to make it fair comparable. Then I can write 2 flow sheets and I can calculate the flows, transports needed, raw material needed, and of course the result is very much depending on how I use the plastic in the end. If I recycle it or use it for energy recovery, I would probably receive different results. And if I put it to landfilling, probably as well another result. So of course you have to know how you treat it and how you use it. And as well, the same for the glass, which is the functional unit of a bottle made of glass compared with a bottle made of plastics. Yeah, of course it's volume, but maybe volume and time. A floor made of wood compared with a floor made of PVC. Of course it has to be square meter and as well time. Square meter and time. Depending on, we don't know for a long time this floor will be functional enough. Therefore we must include time. So time sometimes has to be included, but not always. A t-shirt made of synthetic material compared with a t-shirt made of cotton. Of course we have to think about time here too. And maybe as well, maybe they don't have equal time to start to smell. So maybe this could maybe be included. But at least one t-shirt and time. Drying hands. No, clean hands. Dry hands is the functional unit. By talking about dry hands, you know that we have 2 possibilities in the, at least, official toilets. This blowing machine or the paper. And of course I can compare the blowing machine with the paper with life cycle assessment. Blowing 5 minutes or 1 paper. And I can start to calculate. In this toilet we have chosen to just use paper bags, depending on environmentalist.
I think in Brazil, drying machines is just in airport.
Just in the airport. Okay.
Shopping center.
Or
Shopping
walls.
Now we shall together think about the exercise A, which is about functional units. What do we say about light bulbs? How shall I compare LED lamps with mercury lamps, for example? How shall I do?
Energy consumption.
Energy consumption, then you are doing something in advance. What is the function?
Light.
Light, yeah.
Yeah.
Of course, it has to be the light that we first look on. So the light, lux per square meter. And then of course I have to have identical lightning, and then I can compare two different lamps with each other. Then I can see that probably they don't have identical energy consumption. And this is one of, but you also have, of course, how do you recycle it, what do you do when you find a disposal, etc., etc. So energy consumption is one criteria, but we have to do the whole life chain. How does we extract the material needed for the lamp? And then we have the extraction of the raw materials needed, the use, and then of course the lifetime. So I will choose lux per square meter and lifetime. And then we, of course, will do, when I choose the function, then I can do the flow sheet of the two cases, and then I can compare them. Wallpaper against pen. Square meter and times. It's very similar to floor. People transportation. If I say compare buses with railway or normal cars. If I shall compare the railway, an underground, or buses. I'm a political guy. And I have to decide which former infrastructure we shall have. And of course, LCA can be in two. Of course, the costs also. But of course, you have to check the environmental effects as well. Please think. You can discuss with each other. You can talk with each other if you want to check your ideas. People transportation.
Number of people per square meter.
Number of people is, of course, very good. You have to choose number of persons, which has to be equal, and kilometer. Yeah, people, kilometer. People and kilometer. Then I can compare it. The bus takes 50 people, and we have to run. Maybe we can decide 10 kilometers, 50 people. And then we can count person kilometers. And the railway maybe take 300. Say. And then you need 6 buses to be comparable. And then, of course, how much energy consumption is, and etc. that is needed. Goods transportation. Shall I use aircraft, shipping, or trucks? due to environment, not due to the cost. What shall I choose as a functional unit? Think about the function. Function for goods transportation is
the load that this kind, the load of this kind of transport can afford. For example, shipping, you can put more goods and
you can put
aircraft.
more, yeah.
Yeah.
But how shall we compare?
Volume and weight.
Volume and weight and kilometers. Volume, kilometers, or maybe mass kilometers. Then we have a comparable number. Sometimes we maybe, if it's very bulky, we maybe have to think about the volume. Otherwise, we maybe can choose the mass.
Also the speed, the time that you take to get another place.
Yeah, also, as well. We can include. And you can see, it's very critical to see which is the function, but we know. But we are used in thinking in some way. Of course, we know this is to transport mass or volume. This is to transport persons, newspaper, wall. Of course, it's to cover a wall. And this is a softening texture. Of course, sometimes it's very easy, volume. Sometimes it's more tricky. But if we start to think about which is the function, then it's much more clear. This exercise number B is about the goal and scope. This is actually something that has been very discussed in Sweden, maybe 10, 15 years ago, how to use newspaper when it's finished, when we have read it. Of course, first of all, we think about that recycling is probably the best. But in a country like Sweden, where we have a great use for energy, maybe it could be interesting to use it through a combustion process to recover energy. So maybe it can be interesting. And this is actually what this study is about. It's about goal and scope. And in this case, we also compare two waste management options for newspapers. If we look on the text here, can you see, or is it impossible to read? Here, maybe you see. National authorities are working to prepare a regulation on waste management and recycling for a number of different products. For newsprint, two waste management options have been identified as environmentally better than others: recycling and incineration with energy recovery. Different actors, such as waste management companies, newsprint producers, and environmentalists, argue for either of the options, largely with environmental arguments. So now the authority comes to you, the LCA analyst, to get an objective and quantitative environmental assessment of the two options. Concerning environmental questions, it's very easy to use feelings, not numbers. Of course, incineration is crazy. You cannot destroy the paper. You have to recycle the paper, some people say. And some people maybe argue that paper, what is paper? It's wood. And we use a lot of wood to combustion. Of course we have to use the paper It's not a huge difference compared to wood. And you use wood for combustion. Why not use this paper as a good fuel? It's dry, it has a good heat value. It's crazy to recycle it. It's so complex, and all this ink and all this transport that you need. Let's send it directly to combustion to recover the energy. It's just wood, some other people say. How shall we know? We can find arguments. And then we can use life cycle assessment. Some engineering tool to show this as much of environmental effects will this create. As much of our global warming, as much of the resource depletion, as much of oil, etc., etc. Then we can put a number. And then, of course, if clear, then we can decide due to environmental aspects. But sometimes it maybe can be almost equal. Then it's more tricky. First of all, formulate with that goal and scope. If you remember the framework, goal and scope. Formulate the question of the commissioner as precisely as possible. Formulate the question as precisely. What does he want to know? Therefore, I am to do the LCA study. What shall we write? Formulate the question. Maybe something like this. Something like this. Which of the alternatives to recycling or incineration of newsprint are preferable due to environmental aspects? Of course, we have to reflect on costing, technical solution, and etc. But LCA just include environmental aspects. It's not enough. Of course, we have to have life cycle costing as well. Express clearly which alternatives are to be compared. Then, of course, have to describe that the incineration includes, for example, heat and power production, electricity, and heat. And if recycling, of course, we have to describe as well how much we can recover. Of course, we will never reach 100%. Maybe 75 or 90, something like that. And of course, I have to describe which type of recycling process that exists and that I can use. You have, of course, to wash it. You have this ink that you have to get rid of. And maybe, for example, maybe it also will have a reduction in quality of the fibers in the paper. Maybe you have to put in 25% fresh fibers in any case to make it strong enough for printing. So it's a lot of such a thing to reflect on. When you have thought about that, you have made number 2. Draw a flow chart showing what processes and transportation activities need to be modeled in order to answer the question. Try not to make the flowchart too full of detail at this stage. You can fill in details later during the inventory analysis. Think about whether there are parts of the life cycle that can be omitted. This is of course difficult if you don't know anything about paper production. I have 2 cases. Newsprint. Recycling and incineration. In both the next exercise 4 is about the functional unit. Of course, we have to have the same output. For example, 1 kilogram of newsprint. Probably you have to produce. It depends on, of course, how if you have use units integrated or not. But we can assume that they are not integrated. There we have transport. If this is the newsprint process, we of course have some pulp. And you have maybe, it depends on if it's integrated or not, transports or wood, and of course forest. And we have the printing of the papers, use, transports, maybe some recycling process, and then it's mixed with the pulp. Something like that. And probably we have some output too. It will never be 100%. If we look on the other process, course you have to have the same. Transport. On transport, wood, transport, and we have the forest. We have lots of transports. Here maybe we depends on, of course, if it's directly or not. This we do not know. Here, of course, we have some transport as well. But in this case, we also have electricity. After using, we collect them and send them for electricity production. Is this life cycle comparable with this? This is something that differs. How many products do we break here? One. How many products do you have here? Two. This is what I call an allocation problem. How shall I compare this with this? If we look on this one, we immediately see that if I recycle 5% and we have one here, I just need an input of 25%. And here we see that this one and now we have this flow. And by estimation, if we use 4 times more here, this of course should be for sure be worse. But how to avoid this problem? To make the comparison more fair. What we call it is expanding the system borders. To make it fair, we of course have to have, we have a need of electricity in the society. This will produce 1,000 megawatt hour, kilowatt hour. Of course, you have to have 1,000 kilowatt hours it. This system produces 100,000 kilograms of print, newsprint, and 1,000 kilowatt hours of electricity. And this will do the same. 1,000 kilograms of newsprint and 1,000 kilowatt hours of electricity. Then I can start to calculate and make it fair. And then it's also a question about how will I produce this electricity instead of using this paper. And if it's heavy crude oil that we produce this electricity with. We are not completely sure without doing any calculation at least. But of course, if it's wind energy, I know that we have an excess of wind energy, and it will be wind energy. Of course, it's another question. So therefore, this is of course critical to have the system to be equal. And this is, therefore, allocation is when we have more than one product. For example, in this case, we maybe produce this pulp. We have another line that as well goes to female cat, or whatever. And then also you have an allocation problem. Who shall be responsible of the forest? This or this? So therefore it can be very tricky when you start to do a life cycle. In some way it's easy, in some way it's difficult in another way. It's not heavy math, heavy differential equation to solve. Instead there is a lot of assumptions, estimations, statistics to use. So, draw a flow chart showing what processes and transportation activities that need to be modeled in order to answer the question. Try not to make the flow chart too full of details at this stage. Of course, to do the new print, you of course need more than wood. You're doing it very simplified. Think about whether there are parts of the life cycle that can be omitted. Do you see something that we can skip? Some transportation, but not all. Which transportation can be skipped? For example, you cannot skip boat transportation, depending on that. Here you have to have you have less flow. Here you will have a bigger flow. This transportation, of course, has to be included. But this transport we can skip, depending on. Here we have the same flow. So this part is the same. It is identical. And if my idea is just to compare the two cases, I do skip these calculations. Why put effort on these parts that are identical? But we have to check on this and this, and we have to check on this part. And here you have, of course, a lot of the same, but it's maybe 4 times larger. And you have to think about the recycling process and the electricity process. And the functional unit in this case is not so tricky. If we decide that you can use the same thickness of the newsprint, and we assume that, in that case you maybe can use 1 kilogram. Of course, if we read, think not only about the fact that the functional unit must be expressed in quantitative matrix, but also about relating it to a specific flow in the flow chart. The reference flow we have discussed. Since you are comparing different options, think also about whether there are qualitative differences between a well alternative technical system full for their function. Of course, you could think about maybe if you use new raw material all the time, the paper maybe is a little bit stronger. Because maybe assume. So you have to do this 50% ciclo. But I don't think this like that. But we could at least reflect on it. We have already discussed the allocation problem. One of the allocation problems in this study concerns incineration. Energy from incineration can be used for heat or electricity production, or combined heat and power production. And chilling, they are not mentioned here, but we can also produce chill by heat that you have a need of in an absorption process. This is what we're doing in Sweden now. Should the environmental impact from incineration be split between its two functions, waste treatment and power production, or should the system be enlarged in such a way that the newsprint system is credited with avoided power production elsewhere? This is also a way to do it. You can count on that and make some minus here. Minus subtraction of the action of the effects. If you have chosen to split the impact of incineration between waste treatment and power production, decide on which basic allocation will be made. If you have chosen system enlargement, decide in greater detail how to model the avoided electricity production. Average production, mix, or marginal production. This is also something that is tricky. If we look at average production, how is the mix in Brazil roughly? Hydropower you have how much? Average electricity. 70? We can guess, it don't have to be exact, but what do you think? More or less? 70. And the rest? Fossil fuel. And you have some eolic, but just maybe some percent. Eolic, maybe 2%. And fossil, we have also some nuclear plants somewhere. And this is also maybe 5%. And fossil for the rest. This is 7.2. And then of course we can calculate the environmental effects of this. What will happen if I put on this nuclear power? You do not change. Hydropower is also very stable. But if you need some extra energy, you probably will start some gas turbine. Gas turbines is very easy to start and to close. Then you probably use fossil fuel. And that is the marginal production. If I start some extra machines and you are running the system, we of course probably not will use. If you need a little bit more, you will use fossil. So this is the marginal production, is when you need something more. What will you take that from? You run the hydropower, you run the nuclear, you run the oil, but I need some more. And that is probably fossil. So this is the marginal production. And this we can do. So if we are talking about that we will have a marginal effect here by using this electricity from paper, you will take away something else. What will you take away? Probably fossil. The other things you have, and if I start to produce electricity from this, you of course take away this that is on the top. So in this case, maybe it's not rare to use the comparison between fossil fuel. Do you understand the thinking?
Yeah.
So it's life cycle assessment. If you deepen it a little bit more, it becomes tricky, but not in the way that you are used to. If you have chosen system enlargement, decide in greater detail how the model that avoided electricity production, average production, mix, or marginal production. If I should have done this study, I would probably have chosen fossil fuels and not the mix. What type of data will you preferably use in the study? Choose between international sector average or national average for the specific data. Virgin newsprint, incineration, recycling. What do you think? It exists a lot of publications. We can of course use international sector average or national average or specific data. Well, if you have specific data, I think it's preferred. But if you don't have, I think it's better to use the national data. But if you don't have that, you have to have something. So this is something, this is sometimes a problem. This has been running in Sweden and Netherlands for roughly 20 years now, life cycle assessment. So it exists a lot of data, but sometimes it's missing. And how to do that? Of course, can we use average data as a possibility? You have now made the main methodological choices related to the modeling ahead of you. You have made them in order to answer the question posed under 1. Now summarize what will be the main limitation of the study. In other words, try to be specific about the answer the study will not provide. Of course, there's a lot of details that we don't will understand. What type of review process, if any, will be required for your study? Would you prefer to have reviewers follow the project as it proceeds, or would it be better to have the report reviewed afterwards? This is a governmental decision. Imagine the PP, Partido Popular doing a thing. Now we have to show that incineration is the best. Of course, it will be a crazy opinion. You are talking bullshit. Your recycling is, of course, the best. Should the Green Party say, I guess. So therefore, of course, we have to have a very transparent. Maybe we shall allow, for example, some Greenpeace to be part of the calculations. Sit behind, check what we are doing. Of course, to have some academics involved, or in the Green Party, to involve people that are working as normal people in the party organization, that are well educated and to follow. Check every calculation so you can see that it's completely transparent. And after, of course, the green people would like to have the best solution. So after, of course, they think this is fair done. We trust them. So therefore, of course, it has to be completely transparent. Maybe the best is to have some behind followers. Afterwards, I think it's more difficult. But maybe they don't have the time. But critical review, very documentation, everything has to be done. Where did you find that data? In a Swedish database? How secure is that? Etc., etc. Or rather, people representing the different stakeholders. I think you have to have the different stakeholders with. And of course, experts as well. Market communication. There are already customers asking very specific questions about the environmental performance of the newsprint, and the company must be prepared to answer them. Some of the questions asked can only be answered through applying a life cycle perspective. For the future, they want to be prepared to publish an environmental product declaration. This is something that are discussed, but not completed. But there are some, like we discussed before about that you have it on, for example, washing machines, you have this ABC. This is some type of environmental labeling. And this, of course, similar we can do in all types of products, or maybe more specific. Okay. Shall we take a break?
Yeah.
5 minutes. Okay. This framework we discussed about Golden Scoop. This was an exercise in Golden Scoop. And of course, goal and context, the intended application, which is the product, which is the audience, which is the reason of carrying out the study. This is what we discussed. And of course, it can be for strategic plan, as for this guy, the commissioner that should do the strategic plan of the waste management. Explore and learn about the life cycle. If I am a detergent producer, of course, I should have an interest of the whole life cycle. If I'm a serious guy, I think it's important to understand what will happen from the start to the disposal. And of course, it can be used in eco-design. As a tool for product development, public policy making, and as well marketing. And this is what we did. We thought about the product system to be studied. We designed an initial general flow chart of the system to be studied. Where are the system boundaries? Which principle of allocation are to be used? We expanded the system. What data do we require? Which data quality does we need? Which impact categories and which method of impact assessment are to be used? This we have not discussed yet. Functional unit. I'll say in the environmental toolbox. Of course, we have to reflect on which impact categories that are to be included. Of course, we have to include resource use. I am, of course, interested in how much oil, how much land use, how much electricity, etc., are to be used in the systems that I will compare. Of course, ecological consequences. Global warming, of course we cannot skip global warming. We have these international agreements and we have this crazy weather change. We have had much more storms than normal in 3%. Much more flooding that we are not used to. So the weather, I really think that the weather is changing. That it's not just some, of course we have normal changes, but I think there is a systematic change. Unfortunately, I think that it is like that. So of course we have to include global warming. Acidification is probably not a huge problem in Brazil, depending on you have a different soil than we have. If we look on Sweden, we have had a huge problem with acidification. And acidification, in Sweden we have a lot of lakes. And we have western winds. And western winds are coming from UK. Here you have up here you have the Nordic countries. And here you have UK. And the winds are very often like that. So the pollution in Sweden very much comes from the islands. And they used a lot of coal, heavy crude oil that contained a lot of sulfurous. So they produced a lot of sulfur dioxide that transformed to sulfuric acid. And sulfuric acid decreased the pH of our lakes that died. So we had actually a lot of, especially in the western part, here. The first, here you have the most heavy rain, and so the rain arrives from UK. So we had a lot of lakes that really died, depending on acidification. But now it's better. Now I stopped and increased cleaning in UK. So now it's better and we have put a lot of calcium carbonate to increase the pH. So after 10 years, it's have recovered fairly well, but they still spread calcium carbonate by helicopter, powder over the lakes. So the fish are returning, but also the pH decrease actually makes some heavy metals to be free. So some of the fishes have had too much of heavy metals inside, depending on this acidification. So for us, we have to care about the acidification. And you can as well see some Greek statue or Roman statue that has been completely destroyed in 50 years. So it destroys, of course, the nature, but as well some archaeological things. Eutrophication, do you know what it is? It is when you have too much of fertilizer. It's common in Parana River, as an example. They have a lot of too much of fertilizer inside. And the main rivers where you have a lot of farming activities surrounding or unclean wastewater, you will have waste eutrophication problems. We have a big eutrophication problem in the Baltic, depending on farmer, but mainly on Russia is here. Russian unclean wastewater, Polish unclean wastewater. If you clean very well, but it's global. So we have the same Baltic. And some people discuss, maybe it's better we put more effort to support wastewater treatment in Poland and continue to make ours furthermore clean. Human health, of course. We cannot skip human health. And we can, of course, calculate a number of global warming on these life cycles that I compare. I can calculate a number of how much global warming is the newsprint with recycling responsible for, how much global warming is the newsprint production with electricity responsible for. And then I can compare them and I can choose the best related to global warming. I can do comparative studies, as we discussed, but as well, of course, a standalone study also is interesting. Then I can see which part of my life cycle are creating the worst problems. So we have two general types of essay: accounting. What environmental impact can be associated with this product? What environmental impact can this product be held responsible for? Like electricity from nuclear power in Japan today. Of course, it's the nuclear power production that will cause the increase in human health problems. Close. Change oriented. What will happen if I switch from electricity to recycling? What will happen if I switch from eucalyptus to another tree? That's it. System boundaries, of course, we have to reflect on. Boundaries related to the natural system. Geographical boundaries, there is no problem, not a big problem with acid winds. So therefore, of course, we have to reflect on where we are. Time boundaries. Some pollutions decline relatively fast. Boundaries related to technical system, other product life cycle, allocation problems. Can of course look like this. This here you have in general raw material, extraction, production, use, recycling, reuse, waste treatment, energy supply, transports. You have a product flow and you have an elementary flow. There you have the elementary output, all the emissions, all the elementary inflow. This is a general figure that covers the most in a general way. Allocation can sometimes be needed, but we really wish to avoid allocation by, as an example, expanding the system. If possible, we try to avoid it. I think we don't go in details on the data quality. So I think we end with this for today. On next time we will discuss a little bit more about the techniques, and I will as well talk about the sustainable waste management solution of Sweden, how we do with the waste today. So thank you guys.
Thank you.